Login page. On the login page, there are fields for entering the type, email, and password, allowing users to log in based on their account information. The type field offers two categories, admin or teacher. Furthermore, there is a show password option available, enabling users to view the password they have entered. Additionally, a create account button is provided for users who do not have an account yet. By clicking on that button, they can create a new account. Moreover, two additional features have been implemented. Clicking this button will minimize the application, while clicking the X button will exit the application. Sign up page. On the sign up page, there are several fields to fill in for creating an account. These include first name, last name, username, email, password, retype pass to confirm the password, type, age, and employee ID. Additionally, there is a show password option available for users to view the password they have entered. There are three buttons on the page: create, reset, and click here to log in. After the user fills up all the required information, they can click the create button to create their account. The reset button allows the user to clear or reset the information they have entered. If the user already has an account and wants to return to the login page, they can click the click here to log in button. Homepage. After the user logs in, they will be redirected to the homepage. The homepage consists of two sections, admin and teacher. In the admin section, there are three buttons available: add teacher, add subject, and log out. These buttons can only be accessed by admins, and teachers do not have access to them. In the teacher section, there are two buttons, show all subjects and log out. Only teachers can view their handled subjects by clicking the show all subjects button. If the user clicks the log out button, they will be logged out and exit the application. There is also a back button available on the home page, which allows the user to return to the login page. Teachers page. On the teachers page, there are input fields for entering information such as employee ID, first name, last name, email, age, username, password, and type. Located on the upper right side of the page, there is a table displaying existing teacher data. The table consists of columns for employee ID, first name, last name, email, age, username, password, and type. There are 5 buttons available: add new, delete, view, edit, and reset. The add new button allows the admin to add a new teacher by entering their information in the input fields. The delete button enables the admin to delete a teacher from the system. Clicking the view button allows the admin to view all the information connected to the phpMyAdmin database, including the teacher data. The edit button allows the admin to modify the information of a specific teacher by making changes in the input fields. The reset button allows the admin to clear or reset the information entered in the input fields. Subjects page. On the subjects page, there are input fields for entering information such as subject ID, subject name, section, subject code, description, and teacher ID. In the middle part, there is a table displaying subject data. The table includes columns for subject ID, subject name, section, subject code, description, and teacher ID. There are 5 buttons available: add new, delete, view, edit, and reset. The add new button allows the admin to add a new subject by entering the relevant information in the input fields. The delete button enables the admin to remove a subject from the system. Clicking the view button allows the admin to see all the information connected to the phpMyAdmin database, including the subject data. The edit button allows the admin to modify the information of a specific subject by making changes in the input fields. The reset button allows the admin to clear or reset the information entered in the input fields. All handled subjects page. In the Show All Subjects section, teachers can only view the subjects that they handle. They are able to see and access the information related to the subjects they are assigned to. In the employee table, there are 8 columns: employee ID, first name, last name, email, age, username, password, and type. The employee ID column is set as the primary key and auto-increment. In the subject table, there are 6 columns: subject ID, subject name, section, subject code, description, and teacher ID. The subject ID column is designated as the primary key and auto-increment. Additionally, the teacher ID column serves as a foreign key, referencing the employee table with the employee ID column. I will click on the KLDDB, which is our database name, which contains 2 tables, employee and subject. After that, I will proceed to create or insert data into the employee and subject tables. Next, I will demonstrate how to read data from the database. Next, I will demonstrate how to update data from the database. Next, I will demonstrate how to delete data from the database. What do the CRUND stand for in the context of database operations? Remember that C stands for insert, R stands for select, U stands for update, and D stands for delete. When performing an update operation, why is it important to check for foreign key constraints? In the case of an update operation, it is crucial to check if there is a foreign key constraint. In my scenario, there is a foreign key in the subject table's column called teacher ID, which references the employee ID in the employee table. You can locate this information by clicking on the Structure tab and selecting the Relation View. In the Relation View, you can observe the on delete and on update options. There are 4 options to choose from. If you want the action to be cascaded, which is what I selected, you can choose Cascade. If you prefer no action, then select no action.
Number 1. Import javax.swing.jframe semicolon. This import statement is used to import the jframe class from the javax.swing package.jframe. Is a class that represents a top-level window, typically used as the main window in a graphical user interface application or GUI. Number 2. Import java.sql.connection semicolon. This import statement is used to import the connection interface from the java.sql package. That connection represents a connection to a relational database, allowing you to establish a connection, execute SQL queries, and retrieve results. Number 3. Import java.sql.driverManager semicolon. This import statement is used to import the driver manager class from the java.sql package. The driver manager is a class that manages JDBC drivers. It provides method to register and load database drivers, as well as establish connections to databases. Number 4. Import java.sql.prepared statement semicolon. This important statement is used to import the prepared statement interface from the java.sql package. Prepared statement represents a precompiled SQL statement. It allows you to execute parameterized SQL queries and provides methods for setting query parameters.
Number 5. Import java.sql.resultSet semicolon. This import statement is used to import the resultSet interface from the java.sql package. ResultSet represents a set of results from a database query. It provides methods for iterating over the result set and retrieving column values for each row. Number 6. Import java.sql.sql exception semicolon. This import statement is used to import the SQL exception class from the java.sql package. SQL exception is an exception class that represents an error or exception encountered while working with a database. Number 7. Import Java X Swing or import Java x.swing.table.default table model, semicolon. This import statement is used to import the default table model class from the Java x.swing.table package. Default table model is a subclass of the table model interface and provides a default implementation for managing tabular data. It is often used with JTable to display and manipulate data in a table format.
Number 8. Import Java SQL. This import statement is used to import all classes and interfaces from the java.sql package. The asterisk wildcard character denotes that all members of the package should be imported. It is a shorthand way of importing multiple classes / interfaces from the same package. Number 9. Import java.sql.statement semicolon. This import statement is used to import the statement interface from the java.sql package. Statement represents a statement to be executed against a database. It is used for executing simple SQL statement without parameters.
Number 10. Import java.out.event.keyEvent semicolon. This import statement is used to import the keyEvent class from the java.out.event package. KeyEvent represents a key event generated by a user pressing or releasing a key on the keyboard. It is often used in conjunction with events listeners to handle keyboard input in GUI applications. Number 11. Import javax.swing.jOptionPane semicolon. This import statement is used to import the jOptionPane class from the javax.swing package. jOptionPane provides methods for displaying standard dialogs boxes, such as message dialogs, input dialogs, and confirmation. Import java.swing.jframe semicolon. Import java.sql.connection semicolon. Import java.sql.driver semicolon. Import java.sql prepared statement semicolon. Import java.sql.resultSet semicolon. And import java.sql.sql exemption semicolon. 18 to 27. The code provided is a Java class name lag that extend the java.swing.jframe class. It represents a graphical user interface or the GUI window. This class created a GUI window JFrame for a lag application and centers it on the screen. 192 to 194 exits the program with the status code of 0, indicating a successful termination. 196 to 198 sets the state of the JFrame to iconified or minimize. 208 to 215. This code allows the user to toggle the visibility of password characters in a password field by checking or unchecking a checkbox. When the checkbox is checked, the password characters are displayed as is. And when it's unchecked, the password characters are masked for security purposes. 228 to 231. The purpose of this code snippet is to retrieve user input from GUI components such as button, JButton email, a password field, JPassword field L, and a combo box, JCombo box type A, admin or teacher. It collects the values entered by the user for email, password, and user type. 233 to 235. These variables store the necessary information, database URL, username, and password, required to establish a connection to MySQL database. 238 to 248. This code establishes a database connection, prepares and executes the query to check the validity of user credentials against a table, and retrieves the count of matching rows. The count is then stored in the count variable for further processing or decision making. 252 to 253. This condition checks if the count variable is greater than 0, indicating that a matching record was found in the database, and the login is considered successful. 257. This condition checks if the user type is admin. 259. If it matches, the code creates a new instance of the homepage class and assigns it to the homepage variable. 260. It sets the visibility of the homepage window to true. 261. It sets the admin flag of the homepage object to true. This flag may be used within the homepage class to differentiate between admin and teacher functionality. 262. The homepage window is packed to its preferred size. The location of the homepage window is set to the center of the screen. 263. The default close operation for the homepage window is set to exit on close. 264. A welcome message for the admin user is printed to the console. 268. This condition checks if the user type is teacher. 272. If it matches, similar action as for the admin user are performed, but the admin flag is set to false. 273. A welcome message for the teacher user is printed to the console. 279. If the login is successful, the code disposes of the current window, this, which could be the login window or the previous window that initiated the login process. This effectively closes the current window. 280. If the count is not greater than 0, no matching record found in the database, the code enters the else block. 281 to 284. If the user misspells any of the fields, either in the username, email, or password, they will be unable to log in. 286 to 288. These lines are used to close the database resources in the reverse order of their creation. 289 to 294. This block of code is a catch block that is executed in any SQL exemption is thrown within the try block. SQL exemption is a check exemption that represents an error or an exemption that occurred during the interaction with a database. The try block is used to enclose a section of code that may potentially throw an exemption. By using a try-catch block, any exemptions that occur with the try block can be caught and handled by the corresponding catch block. In this case, the try block contains the database-related code that may throw SQL exemptions. If an exemption occurs, the catch block is executed to handle the exemption appropriately.
Import javax.swing.jframe semicolon. Import java.sql.connection semicolon. Import java.sql.driverManager semicolon. Import java.sql.prepared statement semicolon. Import java.sql.sqlException semicolon. 17 to 26, the code provided is a Java class named sign that extends the javax.swing.jframe class. It represents a graphical user interface or GUI window. This class creates a GUI window or JFrame for a log application and centers it on the screen. 382 to 392. The purpose of this code is to clear the text fields and reset the selected index of a combo box in a graphical user interface or GUI application. 398 to 405. This code snippet is written in Java and is part of an event handler method. Button click this action performed associated with the button click event. When the button is clicked, this method is executed. The purpose of this code is to open a new window or frame and close the current window. 448 to 457. The purpose of this code is to format the input in the JText field employee ID text field by removing non-digit characters and limiting the input to a maximum of 6 digits. 460 to 468. The purpose of this code is to retrieve data entered by the user from various GUI components, such as text fields in a combo box, and store the data in separate variables. 470 to 472. These variables store the necessary information, database URL, username, and password, required to establish a connection to a MySQL database. 475. This line establishes a connection to the database using the driver manager class. The variables URL, DB username, and DB password represent the URL of the database, the username for authentication, and the password respectively. The connection observed is stored in the connection variable. 477. This line defines an SQL insert statement as a string. The statement uses parameter placeholders or question marks for the values that will be provided later. 478. This line prepares a prepared statement object from the connection in the SQL query. The prepared statement allows the execution of parameterized SQL statements. 480 to 488, these lines set the values for the parameters in the prepared statement. The corresponding values are obtained from the variables that were previously populated with user input or other data. 490 to 491, this line executes the insert statement and returns the number of rows affected by the query. In this case, it represents the number of rows inserted into the database table. 493 to 510, this block of code checks if the rows inserted variable, which represents the number of rows affected by the insertion query, is a greater than 0. If it is, indicates that the insertion was successful. If the rows inserted value is not greater than 0, it means that the insertion failed. In this case, it prints a failure message to the console. 512 to 513, this line closes the prepared statement, object statement to release any resources associated with it. 514 to 518, this block of code catches any SQL exception that might occur during the database operations. If an exception occurs, it is caught and the error stack trace is printed to the console. This helps with troubleshootings and identifying any issues related to the database operations.
Import javax.swing.jframe semicolon. This code is Java class code homepage that extends the javax.swing.jframe class, which is a class for creating graphical user interfaces or GUI in Java Swing. IsAdmin, a Boolean variable that represents whether the user is an admin or not. IsTeacher, a Boolean variable that represents whether the user is a teacher or not. SetAdmin or Boolean isAdmin. This method is used to set the value of the isAdmin variable. SetTeacher or Boolean isTeacher. This method is used to set the value of the isTeacher variable. This code represents a basic structure for a homepage GUI class, with Boolean variables to determine the user's role, if admin or teacher, and methods to set those variables. This class creates a GUI window or JFrame for a homepage application and centers it on the screen. This code allows only administrators to access it. If an administrator tries to access it, they will be automatically logged out, and the output will be logged out. However, teachers will not be able to access it. This code allows only teacher to access it. If an administrator tries to access it, they will be automatically logged out, and the output will be logged out. However, admins will not be able to access it. This code segment creates a new instance of the subject page class, make it visible, centers on the screen, sets the default close operation, disposes the current frame, and prints a welcome message to the console. The intention seems to be transitioning to a new page or window while closing the current one. This code segment determines if the user is an admin, and then either provides access to the add teacher functionality or displays a message stating that only admins have access. Afterwards, it closes the current frame or window. This code segment determines if the user is an admin, and then either provides access to the add subject functionality or displays a message stating that only admins have access. Afterward, it closes the current frame or window. The purpose of this code is to handle the event of clicking the J-level back label, which appears to be a back button or navigation element. When clicked, it creates a new instance of the lag class and make it visible while closing the current frame or window. This behavior suggests that clicking the label will navigate the user back to a previous lag page or screen.
Teacher page codes. The imports used are JFrame, KEvent, JOption pane, connection, driver manager, prepared statement, SQL exception, table default table model, star, and statement. Next, in this blue bracket you see, this code sets up the basic structure for a teacher page GUI window and initializes components, while also ensuring that the window appears at the center of the screen when it is displayed. Next, on the red bracket, this code snap captures the event of pressing a key within the JText field employee ID text field. If the preset key is the enter key, it triggers the execution of the insert data to database open close parenthesis method. This allows the user to submit data or perform an action by pressing enter while focused on the JText field employee ID text field. Next, on the blue bracket, the method begins by declaring and initializing several string variables such as first name, last name, username, email, password, type, age, and employee ID. These variables are assigned the values obtained from different text fields and combo boxes in the GUI. Next, on the red bracket, these variables stores the necessary information like database URL, username, and password required to establish a connection to a MySQL database. Next, on the 449, this code is a connection to the database is established using connection details stored in the URL, DB username, and DB password variables. This is achieved by calling the driver manager that get connection open close parenthesis method and passing the connection details as arguments. The resulting connection is stored in the connection variable. Next, on the 451, this code is an SQL query. It's defined as a string variable named insert query. This query uses the insert into statement to specify the table name employee in the columns into which the data will be inserted employee ID, first name, last name, email, age, username, password, and type. The values for these columns are represented by placeholders in the query indicated by question marks. Next, on the 452, a prepared statement is then created using the connection object in the insert query. The prepared statement is obtained by calling the connection.prepared statement open close parenthesis method and passing the insert query as an argument. The resulting prepared statement is stored in the insert statement variable. Next, on the blue bracket, the next step involves setting the values for the parameters in the prepared statement. This is done using the various setString open close parenthesis methods of the prepared statement. Each parameter is identified by its position in the query, indicated by the question marks, and is assigned the corresponding value obtained from the variables holding the data extracted from the GUI. Next, on the red bracket, the insertion query is executed by calling the execute update open and close parenthesis method on the prepared statement object. This method returns the number of rows affected by the query, which is stored in the row inserted variable. Next, on the blue bracket, this code handles the post insertion logic by displaying appropriate message to the user, clearing the text fields, resetting the combo box, and then closing the statement and connection to the database. It also provides error handling for any database related exceptions that may occur during the execution of the code. Next, on the red bracket, the code begins by retrieving the data from text fields and combo box components. Similar to what we've seen in previous code, the values are assigned to variables such as first name, last name, username, email, password, type, age, and employee ID. Next, on the blue bracket, next, a, a new row object is created using an array called row data. This array contains the data retrieved from the GUI components in the order specified: employee ID, first name, last name, email, age, username, password, and type. Next, on the red bracket 510 to 511, this code retrieves the table model associated with the JTable components using the getModel open close parenthesis method. In this case, it assumes the JTable component uses the default table model as its model. Next, on the blue bracket 513 to 514, this code is the new row of data is added to the table model using the addRow open close parenthesis method. The addRow open close parenthesis method expects an array of objects representing the data for each column in the table. In this case, the row data array is passed as an argument to add the new row to the table. Next, on the red bracket 516 to 524, the lines of the code starting with jtext field employee ID that set text and continuing until jtext field age that set text open close parenthesis set the next of each text field to an empty string, effectively clearing the text fields. This ensures that the previously entered data is removed from the text field after the new data has been added to the table. The line J combo box type that sets selected index open close parenthesis and inside of that is 0 sets the selected index of the combo box to 0, which typically represents the first item in the list. This resets the combo box to its initial state, allowing the user to select a new value if needed. Next, on the blue bracket 526 to 529, these variables store the necessary information, database URL, username, and password required to establish a connection to a MySQL database. Next, on the red bracket 532 to 541, This code loads the MySQL JDBC driver, establishes a database connection, and prepares a SQL statement for insertion using a prepared statement. These steps are crucial for interacting with the MySQL database and executing SQL queries. Next, on the blue bracket, 543 to 551, this code sets the values for the parameters in the prepared SQL statement using the setString open close parenthesis method of the prepared statement object. It assigns the values from variables to respective placeholders in the SQL statement, ensuring that the insertion query will use the correct values when executed. Next, on 553 to 565, this code executes the insertion query, closes the statement and connection, and handles potential exceptions. It ensures proper execution and cleanup of resources when interacting within the database.
With the database. 567 to 576, this code snippet provides functionality to reset the input fields in the user interface. When the J button reset button is clicked, it clears the text fields and resets the combo box, allowing the user to start entering new data or select the different values. 578 to 582, these variables store the necessary information, database URL, username, and password required to establish a connection to a MySQL database. 583 to 584, this code is typically used when you want to perform operation or retrieve data related to the selected row in the J table. For example, you might use the selected row index to retrieve data from specific columns of the selected row, update the row, or delete it from the table. 586 to 594. The purpose of this code is to capture the values of the selected row in the J table component for further processing or manipulation. These values can be used, for example, to populate text fields for editing, perform updates or deletions, or display details in other parts of the user interface. 596 to 597, this code establishes a connection to the database, prepares a delete statement using a prepared statement, and utilizes the try with resources statement to handle resource management efficiently. 599 to 606, this code sets the values for the parameters in the prepared statement, allowing the delete statement to be executed with the specific values to delete a specific row from the database data table. 608 to 618, this code snippet executes the delete query, checks the number of rows affected, and provides appropriate feedback based on the success or failure of the delete operation. Try and catch handling errors. 628 to 629, if no row is currently selected, the get selected row close open parenthesis method will return -1. Therefore, it's common to check if the selected row is not -1 before proceeding with further operations that depend on a selected row. This check ensures that an action is performed only when a row is actually selected by the user. 631 to 641, this code blocks checks if a row is selected in the JTable1 component. If a row is selected, the selected row variable is not -1. It retrieves the data from the selected row. The getValue at close open parenthesis method is called on the JTable1 object to retrieve the value at a specific row and column in the table. In this case, It is used to retrieve the values from the selected row at different columns 0 to 7 and assign them to respective variables: employee ID, first name, last name, email, age, username, password, and type. The retrieved values are the converted to strings using the toString close-up and parenthesis method, assuming that the values in the table are of a compatible data type. These values can then be used for further processing, such as displaying them in text fields or performing any required operations. 643 to 651. This code block sets the retrieved data from the selected row in the corresponding GUI components for editing. Each line assigns a retrieve value to the corresponding text field or combo box in the GUI using the set text close open parenthesis or set selected item close open parenthesis method. 653 to 665. The first part checks if a row is selected in the JTable1 table. Selected row is not equal to 1 is used to verify if a row is selected. If a row is selected, the code inside the if the block will execute. Otherwise, the code inside the else. Ulitin ko. Edit mo na lang ha. The first 653 to 665, the first part checks if a row is selected in the JTable1 table. Selected row is not equal to -1 is used to verify if a row is selected. If a row is selected, the code inside the if block will execute. Otherwise, the code inside the else block will execute. If a row is selected, the code is inside the if block displays a message dialog using J option panel that show message dialog close open parenthesis. The message informs the user that a row has been selected for viewing editing. If no row is selected, the code inside the else block displays an error message informing the user to select a row for viewing editing. The JLabel block mouse click close open parenthesis method is an event handler for the JLabel component. When the JLabel block component is clicked, the method is invoked. In this code, it creates a new instance of the log class, sets its visibility to true, and disposes the current GUI window. This likely represents going back to the previous page or closing the current window. 667 to 679. Part of connection again. Let us proceed to creating SQL statement. 680 to 682. In this code, a SQL select statement is created to retrieve all records from the employee table in the database. 684 to 685. In this code, the SQL query is executed against the database using the execute query close open parenthesis method of the statement object. 687 to 696. In this code, a default table model object named model is created to hold the data retrieved from the database. Default table model is a class that implements the table model interface and provides a basic implementation of a table model. The add column close open parenthesis method is called on the model object to add columns to the table model. Each column represents a specific attribute or field in the database table. In this case, the column names added are employee ID, first name, last name, email, age, username, password, and type. These column names correspond to the columns in the employee table. By adding this column to the table model, you are specifying the structure of the table which will be used to display the retrieved data in the JTable1 component of your GUI. 698 to 710. In this code, the while loop is used to iterate through the result set obtained from the executing the SQL query. For each row in the result set, the data is extracted and stored in an array called row. Within the loop, a new object array of size 8 is created to represent a row of data. The elements of the row array are assigned values based on the corresponding columns in the result set. The get int close open parentheses and get string close open parentheses methods of the result set object are used to retrieve the data from the specified columns. The column names used in the result set methods, such as employee ID, first name, etc., correspond to the column names defined in the SQL query. The retrieved values are assigned to the respective elements of the row array. After extracting the data for a row, the row array is added to the model object using the add row close open parenthesis method. This adds a new row to the table model containing the data retrieved from the result set. By repeating this process for each row in the result set, the table model is populated with the data from the database table. Each row in the table model represents a record in the employee table with the corresponding values for each column. 712 to 741. After populating the model object with the data, the code sets the table model of JTable1 to the populated model using the setModel close open parenthesis method. This associates the table with the updated data model, causing the table to display the retrieved data. The code then proceeds to handle potential exceptions and close the resources in the finally block. If an exception of type SQL exception occurs, it is caught and the stack trace is printed. In the finally block, the result set, statement, and connection resources are closed to release any database-related resources and ensure proper cleanup. Each resource is closed in the reverse order of its creation. Closing these resources is important to free up system resources and maintain a clean connection with the database. It helps prevent memory leaks and ensures efficient storage and it helps prevent memory leaks and ensures efficient resource usage.
Subject page codes. The imports that I use are SQL, JFrame, key event, JOption pane, connection, driver manager, prepared statement, SQL exception, default table model, and statement. Next is, this code defines a swing frame class named subject page, E. Initializes its components and positions the frame to be centered on the screen when an instance of the class is created. It is likely part of a larger swing-based GUI application. Next, this code exits the program with a status code of 0, indicating a successful termination. Next is, this code sets the state of the JFrame to iconified or minimize. Next is, these variables likely hold the input values related to a subject for a form or data entry operation. It creates an array, row data, to store the values extracted from the text fields. It obtains the table model of a JTable1 object using the getModel method. The table model represents the data structure and behavior of the table. It casts the obtained table model to default table model, which is a specific implementation of the table model interface provided by Swing for handling tabular data. It adds a new row to the table model using the addRow method. The addRow method expects an array or vector of objects representing the data for each column of the table. In this case, row data is passed to addRow to add a new row with the values retrieved from the text fields. Next is, the purpose of this code is typically to reset or clear the input fields after a form submission or when a certain action has been performed. By setting the text values to empty strings, it ensures that the text fields are visually cleared and ready for new input. This can be useful to provide a clean user interface and avoid confusion or errors when entering new data. Next is, these variables store the necessary information, database URL, username, and password. It is required to establish a connection to a database. Next is, this code, the Java runtime, is instructed to load the MySQL JDBC driver class. This step is necessary to make the driver's functionality available for use in the application. Next is, this code is responsible for establishing a connection to a database, MySQL, using the provided connection, URL, database, and password, username. Next is, this code prepares an SQL insert statement with placeholders and creates a prepared statement object that can be used to execute the query with actual values. Next is, this code sets the values for the parameters of the prepared statement. Each line corresponds to a parameter in the prepared statement, and the values are provided using the appropriate setter methods based on the data type. Next is, this line executes the insertion operation by invoking the execute update method on the prepared statement. The execute update method is used for executing SQL statements that modify the database, such as insert, update, or delete statements. It returns the number of rows affected by the statement, which can be useful for verifying the success of the insertion. Next is, this line closes the prepared statement, releasing any resources associated with it. It is good practice to close the statement once it is no longer needed to free up system resources. Next is, this line closes the database connection, releasing any resources associated with it. Closing the connection is very important to release database-related resources and prevent resource leaks. Next is, the code is enclosed in a try-catch block to handle potential exceptions that may occur during the execution of the code. Next is, this code is part of an event handler for the JText field subject ID component. It is triggered when a key is pressed while the text field has focus. Next is, for this code, it defines a method named insert data to database that is responsible for retrieving data from the text fields and inserting it into the database. Next is, this code prepares an SQL insert statement with placeholders and creates a prepared statement object that can be used to execute the query with actual values. The insert statement object can be used to set the values for the placeholders and execute the query when needed. Next is, this code checks the result of the database insertion operation and displays an appropriate message to the user. If the insertion is successful, the text fields are cleared. If the insertion fails, an error message is shown. This provides user feedback on the outcome of the database operation. Next is, this code is responsible for closing the statement and the database connection after the database operation. In this case, the insertion is performed. Next is, this code is used to retrieve the index of the selected row in a JTable component. Next is, this code is for checking if a row is selected and retrieving the data from the selected row. You can access and utilize the specific values of the selected row in further operations or actions. Next is, this code is to retrieve data into the text fields. The user interface is updated to display the values of the selected row. This allows the user to view or edit the data in the text fields, providing a convenient way to interact with the selected row's information. Next is, this code provides user feedback on whether a row is selected for viewing or editing. If a row is selected, a message is displayed indicating that the row is selected. If no row is selected, an error message is displayed, instructing the user to select a row before proceeding with viewing or editing actions. Next is, this code is associated with the action performed by the Edit One button. By setting the text of all the text fields to empty strings, the code clears the text fields, effectively resetting them to an empty state. This can be useful, for example, when you want to clear the fields after performing an editing operation, or when you need to reset the form for a new entry. Next is, the purpose of this code is to navigate from the current frame to the log frame, homepage frame. When the user clicks on the JLabel back component, it opens the new frame and disposes of the current frame, allowing the user to navigate back or switch between different frames or windows in the application. Next is, this code is used to retrieve the index of the selected row in the JTable component. By using this, you can obtain the index of the selected row in order to perform further operations or retrieve data associated with that specific row. Next is, this code checks if a row is selected in the JTable component before retrieving the data from the selected row. By checking if a row is selected before retrieving the data, the code ensures that it only attempts to access the values from a valid selected row. This helps avoid potential errors or exceptions that could occur if no row is selected. Next is, this code prepares and executes a SQL delete statement using a prepared statement. By setting the values for the parameters in the prepared statement, the code prepares the SQL delete statement with a specified criteria. This statement can be executed to delete the rows in the database table that match the provided criteria. Next is, this code executes the prepared SQL delete statement and retrieves the number of rows affected by the delete operation. Next is, this code checks the value of rows affected to determine if the delete operation was successful or not, and provides feedback to the user about the success or failure of the delete operation and suggests taking further actions such as refreshing the table in the table to reflect the changes. Next is, this code declares three variables used for managing database operations: connection, statement, and result set. These variables are typically used in database operations to establish a connection, execute SQL statements, and retrieve the results. Next is, these lines of code prepare an SQL statement to retrieve data from the subject table and create a statement object for executing the SQL statement using the connection object. Next is, this code is used to create a table model and populate it with data retrieved from a result set. Default table model. This line creates a new instance of default table model, which is a class that represents the data model for a table. It serves as a container for storing and manipulating tabular data. Model add column for subject ID. This line adds a column to the table model with a column name subject ID. Similarly, subsequent model that add column lines add columns for subject name, section, subject code, description, and teacher ID. These lines define the structure of the table model, specifying the column names. The while result set loop iterates over each row in the result set, which represents the result of the executed SQL query. Inside the loop, an object array named row is created to hold the data for each row. The size of the array is set to 6 to match the number of columns. Row 0. Row.set.getInt. Subject ID. This line retrieves the value of the subject ID column from the current row of the result set and assigns it to the first element, row 0, of the row array. Similarly, subsequent lines retrieve values for each columns and assign them to the respective elements of the row array. Model.addRow. This line adds the row array as a new row to the table model. The addRow method appends a new row with the provided data to the model. Next is, this code performs the following tasks. Number 1, the JTable1.set model. This line sets the table model created earlier as the model for the JTable1 component. By setting the table model, the JTable will display the data and structure defined in the model. The catch SQL exception EX or X block is used to handle any potential SQL exceptions that might occur during the execution of the SQL query or the closing of the resources. The finally block is used to close the resources, result set, statement, and connection. It is used in the database operations. This is done in reverse order of their creation to ensure proper resource management. Inside the finally block, each resource, result set, statement, and connection is checked for nullity and closed using the close method. Closing these resources is important to release database connections and avoid resource leaks. If any SQL exception occurs while closing the resources, the exception is caught and it is struct trace is printed to the console using EX or X.print stack trace. Overall, this code retrieves the data from the database and populates the JTable component, the JTable1, with the retrieved data by setting the created table model. It also ensures the proper closing of the resources to maintain good practices for handling database connections.
All handled subjects page codes. The imports that we used are connection, driver manager, result set, SQL exemption, statement, JFrame, and default table model. The code provided is a Java class name log that extends the javax.swing.jframe class. It represents a graphical user interface or the GUI window. This class creates a GUI window or the JFrame for a log application and centers it on the screen. This code snippet initializes the necessary variables for connecting to a MySQL database, including the URL, username, and password. It also declares the variables for the database connection, statement execution, and result retrieval. However, it does not establish the actual connection or execution of any SQL statement. The line connection equal to driver manager dot get connection URL username password semicolon. It establishes a connection to the MySQL database using the provided URL, username, and password. Line string SQL equal to select from subject where teacher ID in, open and close parentheses, select employee ID from employee where type is equal to teacher. This creates an SQL statement that retrieves data from the subject table based on a condition involving the teacher ID column and a subquery. String SQL equal to select from subject where teacher ID in, open and close parentheses, select employee ID from employee where type is equal to teacher. This line declares a variable name SQL of type of string and assigns it an SQL statement and as a string value. Select from subject where teacher ID in, open and close parentheses, select employee ID from employee where type is equal to teacher. This is the SQL statement itself. Let's break it down further. Select from subject. This part specifies the column which is the asterisk and the table which is the subject from which the data will be retrieved. Where teacher ID in, open and close parentheses, select employee ID from employee where type is equal to teacher. This part sets a condition for the selection. It uses a subquery to select employee ID values from the employee table where the type column is equal to teacher. The main query then checks if the teacher ID column in the subject table is present in the result of the subquery. In other words, it selects all subjects that have a teacher ID that matches an employee ID from the employee table where the employee's type is teacher. Statement equal to connection that creates statement, open and close parentheses. This line creates a statement object using the create statement, open and close parentheses method of the connection object. The statement object allows you to execute SQL statements in the database. Result set equal to statement.execute query, open and close parentheses, SQL. This line executes the SQL query stored in the SQL string using the execute query, open and close parentheses method of the statement object. The query result is returned as a result set object and assigned to the result set variable SQL. Is the SQL query string that was defined earlier. The execute query, open and close parentheses method is specifically used for executing SQL select statements that retrieve data from the database. It returns a result set object that contains the result set of the executed query. This code creates a table model using the default table model class and adds column names to the model by adding columns to the table model using model.addColumn open and close parentheses. The code defines the structure of the table. Each column name represents a specific attribute or property of the data that will be displayed in the table. Once the table model is created and columns are added, it can be associated with a GUI component such as JTable to display the data in a tabular format. The table model manages the data and provides method to access and manipulate the data in the table. This code populates the table model with data retrieved from a result set object. It iterates over the result set using a while loop and adds each row of data to the table model. By iterating over the result set and retrieving values for each column in each row, the code builds an object array representing a row of data from the result set. It then adds that row to the table model using model.addRow, open and close parentheses, row. This process repeats until there are no more rows in the result set, effectively populating the table model with the retrieved data. This code involves setting the table model to a JTable component and handling potential errors and closing database resources in the final block. JTable1.setModel, open and close parentheses model, semicolon. This line sets the table model to the JTable component by associating the table model with the JTable. The table will display the data stored in the model. Curly bracket catch, open and close parentheses, SQL exemption, X, curly bracket. This line starts a catch block to handle any SQL exemption that may occur during the execution of the code within the try block. X.print stack trace, open and close parentheses, semicolon. This line prints the stack trace of the caught SQL exemption. It helps in debugging and identifying the cause of the exemption. The following final block is responsible for closing the database resources, which are the result set, statement, and connection, in reverse order. Result set is not equal to null. This block checks if the result set is not a null, and if so, attempts to close it using the close, open and close parenthesis method. This ensures that the result set is properly released and any associated resources are freed. Statement is not equal to null. This block checks if the statement is not a null, and if so, attempts to close it using the close, open and close parenthesis method. This is done to release any resources held by the statement object. If connection is not equal to null, this block checks if the connection is not a null, and if so, attempts to close it using the close, open and close parenthesis method. Closing the connection ensures that the database connection is properly terminated and any resources associated with are released. In all cases, if an exemption occurs while closing any of the resources, the corresponding stack trace is printed. The purpose of this final block is to ensure that the database resources are closed properly, regardless of whether an exemption occurred or not. This helps maintain good resource management and prevents resource leak. This code snippet represents a navigation action where clicking on the JLabel back component leads you to the creation and display of a new log frame, while simultaneously closing the current frame. This allows the user to navigate back to the home page represented by the log frame.
In these lines, the event QU that invoke later open and close parenthesis method is used to ensure that the creation and display of the form occur on the event dispatch thread or EDT. The EDT is a special thread in Swing responsible for handling UI related events. Inside the invoke later open and close parenthesis method, a new runnable object is created and passed as a parameter. This runnable object defines the code that will be executed on the ADT. Next, in these lines, the run open and close parenthesis method is implemented by the runnable object. This method contains the code that will be executed on the ADT. Inside the run open and close parenthesis method, a new instance of the class is created, and the set visible true method is called on it. This action makes the form visible on the screen. Lastly, in these lines, it is assumed that the name classes extend or represent Swing components, such as JFrame or JDialog.